Hello and welcome, students. This is a lecture on LPP, Linear Programming Problem. And in this lecture, this is lecture number 6. And in first 5 lectures, I have done up to exercise 7.3. In lecture number 4 and 5, I solved problems from exercise 7.3. We completed it. And this is lecture number 6. In this lecture, we are going to start with exercise 7.4. It's very simple exercise. What we have to do here is, they say, solve the following LPP by graphical method. We have to solve the following LPP using graphical method. So let's read the first question. See, the first question here is, solve the following LPP by graphical method. We have to solve this LPP. It's a linear programming problem. Now, as you all know, students, that in a linear programming problem, either I have to maximize or minimize. That is, the problem is an optimization type of problem. So the first question is maximize, second, third, fourth, fifth are all about maximization, and sixth, seventh, eighth are all about minimization. So I will solve 2 problems on maximization and 1 problem on minimization. Okay. So from 8 questions, I'll be solving 3 for you. So let's begin with the first itself. See, look at the first question. What does it say? It says maximize z is equal to 11x plus 8y. What is this? This is objective function. Objective function. Something that you have to maximize or minimize, that is known as objective function. Objective function. Same way here, minimize z is equal to 7x plus y is objective function. Objective function. Now, how do I have to maximize this? See, I have to maximize this objective function subject to these constraints. X plus y should be lesser than or equal to 6, x should be lesser than or equal to 4, y should be lesser than or equal to 6, x and y both are non-negative constant, they should be greater than or equal to 0. Okay, so let me start with this question. I will solve the first question, and then I'll solve the first one, and then I'll solve for you the second one, and then I will take the fifth one. I'll take the first one, the second one, and the fifth one. So to begin with, let me solve question number 1. So here, question number 1. So here I write I'm sorry, students, I covered the question. So here, first of all, I'll make a table. In this table, what I write? I will write all the constraints. I will make a table here, and as we have done it earlier also, see, the first column is in equation. I write here in equation. And then here I will write equation. I will write here the corresponding equation. And then the next one that you have, you all know it. What it is? It is the intercepts. What you have is intercepts. You write here intercepts, that is x-intercept and y-intercept. And here what we have, this is the final one, that is solution set, okay, with respect to origin. That is, it is origin side or non-origin side. So let's begin, students. The first inequation is x lesser than or equal to 4. Now you all know x lesser than equal to 4, the equation is x equal to 4. And for x equals to 4, you all know this line is what? See, this is y-axis, this is x-axis, x equal to 4 is a line parallel to y-axis and cutting the x-axis at 4. So the x-intercept is definitely 4. So the point of intersection of line and x-axis is what? 4, 0. Now, what will be y-intercept of this line? The y-intercept of this line is not applicable. So just put a dash. See, this line x equals to 4 will never intersect y-axis. So put a dash. And then it comes to the next one is about the solution set, which we will decide later. As you all know, this one we will decide later. Then I go to the next one. And what is the next one? The next one is y less than or equal to 6. So this is y equals to 6. Now you all know that line y equals to 6 is parallel to. So here students see line y equals to 5 is this line, and it cuts the y-axis at y equals to 6. Sorry, it cuts the y-axis at 6, 0. So the x-intercept is not applicable. Y-intercept is what? 6. So the point of intersection, I'm sorry, this is 0, 6. I'm sorry. The point of intersection is 0, 6. And this we will come to it later. After this, what I do? I go for the next. The next is the line x plus y is x plus y lesser than or equal to 6. Okay. What is the, I'm sorry, this is not the line, it is the inequation, that is constraint. X plus y lesser than equal to 6. The corresponding line is x plus y equal to 6. And the x-intercept for this line, I will have to put y as 0. So 6. So the point of intersection is 6, 0. When I put x 0, so the y value is again 6. And this is 0, 6. Okay. So after having done this, what is next step, students? The next step is now I go for the graphical solution. I will have to plot the graph, which you already know how to do this. Okay. So in order to plot the graph, see, I'll have to plot the graph. So what I do is, see. Okay, one more thing, students. One more thing, x greater than equal to 0 and y greater than equal to 0. Look at these two. Okay, you don't have to bother about these. Why? Because they are negative constants, so they do not have any place in the table. Don't worry about that. Okay, so I will go for the plot now. I will, in exam, if they provide you a graph paper, well and good. But if the graph paper is not provided, don't worry, you can do it. You can do it even on normal ruled paper that you have. I will show it to you how to do it. So let's begin. What I do is I draw the x-axis and y-axis. See, students, this is y-axis and here I have x-axis. And remember one thing, students, that since I have the since I have the non-negative constraints, so I don't have to have the prominent second, third, and fourth quadrant. Okay, everything will be in the first quadrant. So for name's sake, I have drawn the second, third, and fourth quadrant. So this is x-axis and y-axis. Here you have origin, x dash, y dash. Okay. Now see, the maximum of x that I have is 6 and the maximum of y also I have is 6. So what I do here is, see, I go for the numbering. So this is, I go for numbering. And as you know, this is, I'll take here 1, then 2, 2, this is 3, this is 4, 5, and 6. Okay. This is 1, 2, 3, 4, 5, and 6. Students, you can always use your scale, the ruler that you have. Always you can use that ruler and see 6. I think the normal width of a page that you have is definitely minimum. Minimum you will have 12 centimeters, close to 12 centimeters you have. So, you know, so here what I am doing is, I write here scale, I write, okay, I write the scale as 2 centimeter equals to 1 unit, okay, on both axes, So what I'm doing, you know, I'm taking 2 centimeter and for 2 centimeter, I'm taking 1 unit. This is 1, 2, 3, 4, 5, and 6. Now see here, I go for these lines. So the first line I have is x equals to 4. So I plot the line x equals to 4 and you know what is that line. See, x equals to 4 is, try to understand, students, this is x equals to 4. Here is line x equals to 4. Okay. It is parallel to y-axis. This is x equals to 4. And remember, the moment you draw the line, the next thing you will do is you will write the equation beside that line. Okay. And now I go for its solution set. Look at this. What is it? It is x lesser than, look at this. It is x lesser than or equal to 4. Now see, x equal to 4 is the set of all points on the line. And lesser than 4 is what? Lesser than 4 is the set of points which are on the left of x equals to 4. So I understand that this side I have to put cross. You understand? These are very faint lines, very faint, you know, very light pencil you have to use and put this cross. It means this side I don't have to go. See, fourth quadrant anyway, you don't have to go. So this is it. Now I go for the next one. Okay. And here I write. What do I write? I write, see, solution set with respect to origin. solution set with respect to origin was the call. So this is origin side. This is what the solution set here is, origin side. Now I go for the next. The next is x is y equals to 6. So y equals to 6 is this line. You can check. So first I will draw y equals to 6. So I drew y equals to 6. And then students, this is y equals to 6, and then immediately beside that I write y equals to 6. Again, what do I have? I have here y lesser than or equal to 6. See, y equal to 6 is the set of points lying on the line. And y lesser than 6 is what? It is all those points which are below this line. So what you will do? You want y lesser than 6. Remember, look at this. You want y lesser than 6. So all the points below that are the graphical solution. What you will do is, above that, you will put the crosses. You will see this, you will put cross all this. Okay, next. Then you have the next one, that is x plus y equal to 6. So I first plot x plus y equal to 6. I plot first x plus y equal to 6. So how do I plot x plus y equals to 6? See, I will have to go by intercept 6, 0 and 0, 6. So 6, 0 is here and 0, 6 is here. Okay. So 6, 0 and 0, 6. And then I plot the line. I plot the line. Say 6, 0 and 0, 6. I plot the line. I plot the line. And as I told you, students, immediately what you will do, you will write the equation. So this is x plus y equal to 6. What is next? You have to go for the solution set. See, here also it was the origin side. Here also it was the origin side for y lesser than or equal to 6. And for this one, it's again, x plus y lesser than 6. Again, you can check here, students, x plus y lesser than 6. X plus y lesser than 6. How do I decide it is this side of the line or this side of the line? How do I decide? Very simple. I will take the coordinates of the origin and substitute here. So when I substitute, I get 0 plus 0 lesser than 6. So 0 lesser than 6, which is true. Now, since it is true, what I understand? I understand that the coordinates of origin are satisfying the inequation x plus y lesser than 6. So the graphical solution will contain the origin. So once again, what I will write, the solution set is the origin side. It is the origin side. Okay, this side. So what I will have to do is, my dear students, I'll have to put crosses here, put cross like this. Okay. Now you can understand in first quadrant, so where you do not have the cross, you do not have the crosses here. So this is the solution set that you have. This is the solution set that you have. You will shade it. You will do the shading. Always remember, students, that make sure that from the corner point you take one line from the corners. From the corners, always make sure that you take a line, because then that thing, it distinctively makes it look proper. Okay. Now see, students, after this, what you do next is the shaded region, you write S. Okay. and okay, you write S there, and here I will start writing ahead of this. So see here, I write, this is my graph paper done. Please understand, you will take a eraser, and then you will just, these lines you will erase. You will erase them off, please. I am erasing. See, these type of questions, students, all the students are happy. Why? Because this is sure shot marks that you are going to get. You simply have to understand, you need to have the basics of straight lines. Okay, don't forget to remove them all. Before you go for the next question. Okay. Students, after this, what I write is, I write here, that is whatever I'm writing is below this graph. Below this graph, you will start writing. You will write the shaded region. The shaded region is the feasible solution set. Feasible solution set. Okay, the shaded region is the feasible solution set. Okay. Now see, I will name it O. I write here A, then B, and then C. I write here the polygon, which is a quadrilateral, the polygon OABC is a convex polygon. It is a convex polygon. See, students, the next thing that you have to do is you have to get the coordinates of these vertices. So what are the coordinates of these vertices? See, you said polygon OABC. What are the coordinates of A? A is, O is 0, 0. A is 0, 6. B is, you can check B. You have to solve, see, for the coordinates of B, you will have to solve these two lines simultaneously. So X is 4 and Y is, see here, X is 4 and you will substitute. See, you see here X is 4. Why? Because point B lies on this line where X is 4. So X is 4 and for Y, X is 4 and for Y, you substitute X in this equation. So Y is 2. 4 plus Y 6. So Y is what? 2. So what are the coordinates of B? B is 4, 2. You will have to solve these two equations simultaneously. So I got here B as 4, 2. What is C? C is 4, 0. C is 4, 0. Okay. Yeah. Now remember, students, after this you are going to write one very important statement, and that is known as corner point theorem. It is known as corner point theorem. So here I will write by corner point theorem. You can either say corner point theorem. You can either say corner point theorem, or you can say convex polygon theorem. Now, what does this theorem say? This theorem says that the maximum or minimum, here it is maximum, but the theorem says the maximum or minimum of the objective function is attained at least one of the vertices, that is at least one of the corner points. See, the maximum of this objective function will happen at least at one of the vertices. It may be either at vertex A or at B or at C or at O. Okay. So what I will basically do now, see, I shall now be going for calculation of objective function at these points. Okay. So please excuse me, students. I am going to now remove this part and go ahead. So here, okay, or that is not required. I can write here. Yeah. So see, you don't write on the graph. You write it below all this. See, after this, I am writing here. Okay, so see, I write Z of A. Z at A. Z at A. This is the way we write. Z at A. What is it equal to? It is equal to Z is 11x. So Z at A is Z11 into X. What is X for A? What is X for A, my dear students? It is 0. Okay, or I'll do one thing. I'll write like this. See, Z at A is equal to Z at 0, 6. A is 0, 6. You can check. The coordinates of A are 0, 6. So that is, what is objective function? You have it here, 11x. So 11 into 0 plus 8 into 6. So what is that equal to? ZA you got 48. Then you will go for ZB. You have to calculate at the corner point. ZB is Z at 4, 2. That is 11 into 4 plus 8 into 2. 11x plus 8y, 8 into 2. This is equal to 44 plus 16, and that is equal to 60. So you got ZB as 60. ZB as 60. Then you have ZC. What is ZC? ZC is nothing but Z at 4, 0. This is 4, 0. C is 4, 0. So you have the objective function is 11x plus 8y. So 11 into 4 plus 8 into 0. So you got 44. So this is ZC. ZC is 44. Now you understand, students, ZO will be 0, 0. ZO is going to be 0. So now you understand that the maximum is happening where? The maximum is happening at ZB. Okay, so what will be my final answer? I understand that objective function, the objective function Z equals to 11x plus 8y is attaining its maximum value at x equals to 4 and y equals to 2. At x equals to 4 and y equals to 2. This is what is the answer. Okay, please copy this much fast. See, students, its final answer will be, therefore, the maximum value of Z occurs at point B, 4, 2, that is when x is 4 and y is 2. This is the final answer.